Alrighty. Good afternoon, good morning, good afternoon, good evening, those who in whatever time zone you're in. This is the Edge SIG call for 13 February 2024. Your host today is going to be myself, David Eberly. We have a couple announcement or two, and then we have our main speaker. One of the announcements is that the OpenShift Commons or OpenShift Cube and KubeCon in Paris is still going on. They are actively still looking for individuals to sign up and go to the OpenShift Commons gathering at KubeCon Europe. If you look on the agenda side, that information is still there. That is both both an in-person and a virtual gathering for that KubeCon in Paris. Also, if you do have a question and we don't necessarily get a chance to cover that question or put that question in the answer in the notes, please look at the notes to make sure the note takers covered that information. Today's topic is going to be, we have a guest. His topic is going to be clearing a cluster of 1 to 3 nodes using NUX, a router, and some code. The gentleman's name is Charro. I'll have him introduce himself and go from there. Sir, if you will, Mr. Charro, if you will go ahead and go from there, the floor is yours, sir.
All right. Thank you, David. And thanks to the Edge SIG for the invite. I've actually been an active member of the OKD working group for quite a while. Not quite so active of late, as I've been spending most of my time doing more app development, app delivery type work and less on the infrastructure side. But I'll do just a real quick intro of myself and then jump right into the topic, because I think there's going to be some elements here that will be of interest to you guys. So
Can I jump something real quick for you? If you have
please
a
do.
if you have a excuse me, sorry about that. If you have a camera, it'd be good to see who's on the and be able to talk from a guest
Sure.
standpoint,
Let me
if you
turn
can.
that briefly. Yeah, I'll turn it on. I'll turn it off again because as you will see, there it goes. I am sitting in the forward stateroom of a sailboat. So bandwidth is a little bit less than what I normally have. My wife and I recently bought this boat. It's down in New Bern, North Carolina. So that's where we are right now. I am working remotely from a sailboat. So I'm Charro Gruver, currently with Red Hat. I've only been with Red Hat about 3.5 years. Uh, Spent the previous 20 plus years as a customer of Red Hat. I started my career in the infrastructure side of thing, as a Unix systems engineer doing C code for operating system level stuff and lots of automation and administration. From there, grew into an architecture role and started moving from the right to the left, if you will, over into app delivery and information security. So, throughout my career, I've spent time in most of the practices that you find in IT. Networking is probably where I'm the weakest, but I do have some networking chops. So did a lot of work as enterprise architect, led some architecture organizations, and eventually jumped the fence and joined Red Hat as I was spending most of my time working with Kubernetes ecosystems and OpenShift in particular. So it was a good fit for me. And, starting out with my roots in infrastructure, I've always been a gearhead. And when I get into something, I get into it pretty big. So I'm going to go ahead and turn on my screen share now to jump into this topic. And let me know you guys see my screen okay?
Yep, looks great.
Yes, we
Okay.
can.
Good. I'm going to turn off my video now just to preserve some bandwidth. Because, like I said, this isn't the snappiest network. I will give you one quick little anecdote. At our home marina, which is up in Topping, Virginia, on the mouth of the Rappahannock River near the Chesapeake Bay, I'm not sure. I think maybe a Verizon executive has a yacht or something somewhere near there because sometime this last year they lit up a 5G ultra wide tower. And I spent the day or two working at anchor out in the middle of the mouth of the Rappahannock River, which is about 3 miles wide at that point. So about a mile and a half from the marina out in the water with that 5G ultra wide signal and my Verizon hotspot router. I was getting in excess of half a gigabit of bandwidth down, and if I'm remembering correctly, it was about 120 megabits of upload speed. So, edge computing doesn't have to be slow if you're close to the right networking resources. It is actually faster than our Cox internet connection at home. So, like I was saying, always been a bit of a gearhead, and when I get into something, I generally like to really dig in deep and learn as much as I can about the topic. So, I started building a home lab. Back in 2017 is when I bought my first Intel NUC form factor machine. I love those little machines because they are so very portable. Here's a picture that I had thrown up on a blog post last year of just how portable these things are. That little Intel NUC that you see right there sitting underneath that GLINet travel router, that's a 12th gen of the Nooks in their slim form factor. And that little guy there is an i7 that has effectively 16 CPUs when you factor in the hyperthreading, and 64 gigabytes of RAM and two M2 storage slots. So that's a lot of compute that is crammed into a very tiny form factor, which is why I liked them so much. Well, as my lab started growing and I started getting more and more into the various workloads that can be run on a Kubernetes cluster and Red Hat's OpenShift specifically, I found myself having to reconfigure the lab quite a bit. I'm going to show you a slight shock and awe picture here, just real quick. Um, this is this is an older picture of some of my lab gear. So as you can see, it became a almost an addiction. Actually, it probably is an addiction. I have more of these little machines than is probably healthy, but I love them all and I enjoy playing with them. What you're seeing right here is a cluster setup that represents three distinct data centers as though they were provisioned in multiple network regions. And I'm showing you this not just to show you what a big giant stack of Intel NUCs looks like, but to explain to you the problem that I started encountering. Because it's one thing to have a setup that looks like this, where I can attach a keyboard and a monitor to the little machine, and I can hand type commands into it, and I can plug storage into it. I can boot off of an ISO, and I can muddle my way through getting an installation done and building an OpenShift cluster and having it up and running, and configuring my DNS and configuring my router in the router and setting up my firewall and all of that. But once I have a setup that looks something like this, that becomes a very time-consuming endeavor. If I need to make configuration changes to one or multiple of these devices, or if I need to destroy and rebuild an entire segment of it, if not the entire lab itself, having to set up KVM switches or move monitor and mouse and keyboard around and plugging USB drives into each of those things, you can see it becomes onerous very, very, very fast. And so I recognizing that I was going to be spending a whole lot of time setting up and a lot less time actually using the lab, I took the opportunity to start building some automation for myself. Now, the automation that I'm going to show you is very opinionated to the gear that I use in my lab. So it's not like it's something that is generally available to just apply to any gear that you want to use. But the patterns and the concepts that I'm going to relate to you, I think will be very transportable for application to other edge use cases where I need to manage devices at a distance that I may or may not even have physical access to. And that's sort of the philosophy that I take as I approach the automation of the gear that I have in my lab is, as much as possible, I don't want to touch the device. And aside from actually plugging the power and the network cables into them, that is the scenario that I have right now. Is I can build and I can tear down OpenShift clusters on these bare metal devices. I can reconfigure the network. I can set up or tear down different regions without having to touch the device at all. My hands remain on my workstation close to my keyboard. And so that's sort of what I'm going to walk you guys through today, as I talk you through the journey that I went on to build the automation for my lab. So like I said, the machines themselves, they're Intel NUC form factor. That in and of itself isn't really special, right? You could swap these NUCs out for just about any Intel based machine, and the automation that I've built will work for you. What is somewhat unique to the lab is the network gear that I'm using, because I have built that portion of the lab around OpenWRT, which was one of the main reasons that I chose these GLINet travel routers, because they're built on OpenWRT. They have pretty beefy hardware specifications for what they are, and so they're very, very utilitarian. And combined with something like a Raspberry Pi, which you can also run OpenWRT on, I'm able to build a consistent platform for my network or my peripheral edge devices, such that I only have to deal with two operating systems. The network operating system, if you will, is OpenWRT, and the OpenShift or Kubernetes side of it is all Core OS. So
Did we lose him?
Sounds like.
We might have lost him. Hold on a second here. Hold on. To answer your question, we'll put the WRT question in the chat. OpenWRT is basically an open source replacement software OS, for lack of a better term, software for certain kind of routers. Exactly, Lester. It was the reason why it's, why it's OpenWRT is because it was the old Linux, or not Linux, but old Linksys WRTG routers that they originally, I'll just say, I don't say hack's not the right word, but replaced the software with Linux type branded or Linux type software where you can load packages, you can do a lot of stuff with it.
Hey guys, am I
Basically,
back?
yes, you're back now.
Oh, good, good. So I had to switch networks. The Marina Wi-Fi chose that moment to betray me. I think the router I was connected to has recovered, so I'm gonna try real quick to switch back to it. So I'm connected to the lab. Give me 1 second here. You're gonna lose me for just a moment.
Basically, from an OpenWRT standpoint, it's putting a quasi Linux kernel on that old Linksys WRT router.
Okay, am I back now?
You are.
Excellent. Okay. David, what was the last thing you guys heard?
Last thing we heard was you were talking about WRT and your lab and how you were doing the two WRT and the
And CoreOS.
CoreOS.
Yeah, okay.
That was the last thing we were talking about, and you're like mysteriously gone.
Yep, yep. The Wi-Fi Marina betrayed me at that moment. But it's back. Fun with networking, right? Which actually is another another thing that I'll talk a bit about that I built into this lab is resiliency from those interruptions because networks are inherently unreliable. Always have been and probably always will be. So yeah, the choice for OpenWRT for the peripheral devices really was, and I think David, you were talking a bit about the history of OpenWRT. It's a Linux operating system that is highly opinionated toward network devices and network appliances. So it's a Linux-based operating system that out of the box is pre-configured to do lots of networking stuff. And that's why I chose to use it, because its primary purpose in my lab is to manage the network. It's responsible for the routing, it's responsible for DNS, it's responsible for firewall. But because it's a Linux operating system, I can also make it do other things. So as for example, you'll see hidden behind the leftmost stack of Nooks that Raspberry Pi sitting there. That Raspberry Pi is running OpenWRT,
Can
but
you, hey, Charles, can you share your
sure.
screen, please?
Oh, it didn't.
No.
It didn't save the share. Look at that. Okay. Is it back?
There you go. We're back.
Perfect. Okay. That little Raspberry Pi hiding behind there, like I was saying, is also running OpenWRT, but that is not part of the network infrastructure in my lab. What that little guy is doing is providing all of the ancillary infrastructure that's necessary for installing, updating, and curating OpenShift and the applications that might be deployed on the OpenShift clusters. So the purpose for the Raspberry Pi is predominantly to run a Nexus, a Sonatype Nexus artifact repository instance, which is serving as an image registry for the container images, inclusive of the images that are used to actually install the OpenShift cluster. It also is a Maven Nexus mirror and a Node NPM dependency mirror, as well as just a general HTTP-based artifact repository for things that the clusters running in the lab might need. And this is the resiliency aspect of it. I did this, one, to make it portable so that if I end up in a place with really, really crappy bandwidth, I not only have my lab gear with the operating systems and the cluster components already installed and running on it, but I also have all of the things that I might need to actually run applications on it, even if my network is not the greatest. So those are kind of the components, and I'm not sure, I'll repeat really quickly because I'm not sure if you guys heard the piece of it about the networking. I had told you in this particular image that I snapped here, this was a 3 data center, a 3 region setup. Well, these 3 GLINet travel routers that you see right here, they are actually providing the network for each of those regions. So this is deployed like it was a geographically separated data center, where each of them has its own edge network provider. They are all then linked to this central router here that provides the internet gateway. So I've also built this out so that the firewalls can be configured in such a way that I can manage the traffic between the 3 distinct data centers. There's actually another stack of NUCs that you can't see that's behind this one here that is a control plane for the 3 data centers and also has its own network. So I say all that to sort of lay out the level of complexity of what I'm playing with here and give you some background of why it was necessary for me to build the types of automation that I built. Because I like to tear this down and reconfigure it. New OpenShift versions are released, or new upstream, nightly builds that I might want to test. And so I need to be able to tear this down and rebuild it in an hour or less. And that was kind of my goal when I started writing this automation. I do have a blog that I maintain that hasn't been getting much love lately. And I'll share this with you guys in the Slack channel afterwards if you don't already have the links. I do have
It's in the show notes too, by the way. If you click
okay.
on his name, it's on there as a link.
Okay, excellent. I do have a new post that I need to get up that includes these latest changes that I'll be walking you through, because there's some new methods for installing OpenShift that don't require an external bootstrap server. That wasn't available until just a few weeks ago for OKD, the community OpenShift, which is why I've been holding off on this post. But now that that is available, I need to get this post done so that I can show folks how to use the latest iteration of this lab that I've got. So I'm gonna pause here real quick, see if there's any questions, and then I'm gonna take you on a quick tour of how I built the automation. It's going to be less of a code review and more of a just this is how I approached it.
I do have a question, and just kind of off the wall. So why is it kubelet, and why is your license plate expired?
The license plate is expired because that's an old picture. It's kubelet because kubelet is the core daemon process that runs on a Kubernetes node that makes it part of a Kubernetes cluster. Why it's on my license plate, that just probably tells you more about me than you needed to know. But yeah, my license plate is up to date, so Highway Patrol won't be stopping me on the way home. That's just an old picture. All right, so the automation is in a GitHub repo in my GitHub. that I named Camaratos because I wanted to stick with the nautical theme for Kubernetes stuff, and because these shell scripts do all of the dirty work for my lab, I geeked around a bit trying to find the Greek word for the person that cleans the toilets on the boat. And the closest I could find was the Greek for a ship's steward or cabin boy. And so that's Camaratos. And that's what I named the Git repo for all of my scripts. Now, what I'm going to be showing you is actually in a branch, this agent install branch. The main branch I have kept with the older code that still works with my more recent blog posts about it. So I haven't merged this agent install over to the main branch yet. Once I do that, then the older blog posts will be deprecated. So when I get to that, then, you know, I'll make sure and I include that in the docs that those older ones are now deprecated, because this uses the new agent install features that are part of OpenShift 4.14 and going forward. So an OpenShift installation requires a few things up front. If it's going to be a single node OpenShift cluster, it doesn't need a load balancer, right? Because all of your ingress and egress out of the OpenShift cluster is going to be through a single IP endpoint, because you only have the one node. So if you're building a deployment that looks something like this, where the whole OpenShift cluster is just a single node running on the machine, you're not going to need a load balancer component, but you're still going to need some routing and some DNS that is required for the OpenShift cluster. So one of the first things that my automation does is it manages bind on this travel router. Using OpenWRT and using the GLINet routers, I leverage bind on the router to provide DNS for the whole lab. And then it also is able to forward upstream to, you know, to things outside of the lab. So you can still get to Google and Yahoo and whatever. So that's one of the first things that I have to configure. And what I'll do is pop over in here real quick. And is this font readable on your screens?
Yeah, I
You
can
get,
read it. I
you can
think we
see
can
it?
read it.
Okay, perfect. So what I'm going to do, oops. Okay, so this is the directory that has all of the bind configuration in it. And what the configuration looks like for a typical OpenShift cluster. In your forward resolution, you need a wildcard to access the ingress of the OpenShift cluster, that then the OpenShift cluster itself will handle to complete the DNS resolution for application workloads that are running in the cluster. You need an API entry for the Kubernetes API, and you need an API internal entry for the nodes to be able to talk to one another. Now, the entries that I'm showing you right here, this is for a 3-node cluster. So you see that these first 3 entries, the wildcard, the API, and the internal API, are all pointing to this 10.11.12.2. Well, that 10.11.12.2 is an IP address configured on this router itself, hanging off of one of the LAN devices. And so it's actually pointing to the the network endpoint that Nginx is running on this router. So that's another piece of this is when you have more than one node, you need a load balancer so that you can, one, have resiliency across the nodes, and two, spread the load to, two or more ingress endpoints into the OpenShift cluster. I'm using Nginx for that. Running Nginx on the router so that the router is providing not only the DNS and the routing and the firewall, but it's also running as my load balancer. It's another reason that I like OpenWRT. It's another reason that I like these GLINet travel routers because they have enough memory and CPU that they can provide those functions. The other thing that you need from a DNS perspective is reverse lookups. And so I have reverse entries for each of the components that are part of the cluster. So that's the DNS aspect of it. The Nginx configuration looks like this. So it is set up to load balance across the three nodes, 60, 61, and 62, for the various endpoints. 6443 is the external API endpoint for Kubernetes. 22623 is the internal API endpoint for Kubernetes. And then 443 is for the HTTPS application traffic. And port 80 is there as a legacy holdover for anybody that still is holding out and not using HTTPS. But in most cases, the 80 endpoints automatically redirect to the 443 endpoint. And then the listen ports are on the .2 endpoints for the cluster, which is configured on this router. So that's some of the basics of the networking pieces that you have to have set up. The way I have this configured for doing the installations is I'm taking advantage of a Pixie install paradigm that's been around for quite a while called iPixie. Let's see. Where are those on here? Let's see,
I've got a question for you if you don't mind.
Sure.
While you're
Yeah,
looking for that.
Go ahead and ask while I'm navigating to the
You said that you have a HTTPS 443 IP address for one of your server or for your server stack. In your router here, do you have a cert that you put in there, or do you just use your self-signed certs? Or how does how does
Yeah.
HTTPS work in a OpenWRT router slash your setup? Does
Yeah,
that make sense?
in my environment currently, I'm letting OpenShift generate self-signed certs, and then I am trusting those certs that the OpenShift cluster generates. I have set this up. I haven't done it in a long time, and I never included it in this automation. You can set it up to use trusted keys that you get from an upstream provider. But because I build and tear these down so often, I just use the self-signed cert that the OpenShift cluster generates, and then it has its own capabilities for managing certificates. So I use it to generate additional certificates, just using the self-created key as the trust. All right, so here's an example. So what iPixie allows you to run a default script effectively during the Pixie boot process, which differs from traditional Pixie booting, where effectively you have to give every machine the same image. iPixie allows you to have system-specific configurations that you can hand it to. And one of the ways it allows you to do that is by using the MAC address of the machine that is making the Pixie boot request. And that's what I'm taking advantage of. So this right here, this boot.ipixie, this is my default Pixie boot file, which the only entry that it has in it is a chain that says replace what you have here with the contents of this file, where this file is dynamically determined from the MAC address of the machine with the colons substituted for hyphens. And so you can see in the iPixie directory these MAC address files with a .ipixie on them. If I cat one of those, let's see. Oh, 5035. There we go. Grab one of those. This then has the actual boot instructions for this particular machine. These iPixie files are generated by my automation. So when I run a deployment of a lab, part of the automation is it creates this iPixie file that directs this particular machine when it boots up to use this specific kernel or this specific init RAM disk and this specific kernel with these options when it boots. And so that's how I overcome the problem of having to generate ISOs and attach ISOs to machines and then boot the machine from the ISO. Instead, I'm creating initial RAM disks that have the necessary personality for the particular machine, so that they can boot off of a image that will give that machine the configuration that it needs to join the cluster. And so I can that way control different hardware configurations. One machine might have 2 SSDs installed and another machine only has 1 SSD. I might need one machine to have slightly different network configuration tuning parameters than another machine. I can control all of that through this mechanism because I can boot each one off of its own particular personality. And that gives me the ability to control the ignition files for the particular machines. All right, so I'm going to pause there. Assuming that you guys are at least somewhat familiar with the CoreOS ignition process and things with OpenShift, is that a fair assumption?
Yeah, I think it's a fair assumption.
Yes, perfect. Okay, so how does all of this tie together and how do I make it declarative? I'm going to pivot over now to the code for the automation. I wish I could make this little zoom bar move or go away. Ah, there we go. Hide it. There. All right. So The configuration is declarative. The top level of my configuration is a lab configuration file. And I've built all of this off of the YAML paradigm, sticking with, how Kubernetes itself is configured. So I built all of this to consume YAML files to give things their configuration. So within my top level configuration is where I define the highest level things that are consistent across the entire lab, like the install host, if the files for the installation are going to be located on the router or on a separate Raspberry Pi, what the router's IP address is, what the base central network is, what the base domain is, all of those things I configure in this top level file, including the versions of the ancillary software that I'm using, like the OpenWRT that goes on the Pi, GitT, Keycloak, Apicurio, Nexus, things of that nature are all defined here. I do have a section for subdomain configurations. Like if I'm doing a multi-region deployment, like you guys saw in the picture, where I include the network definitions for the routers that are going to hang off of the internet gateway so that they get their IP addresses, their networks, their net masks, that configuration information. And then this other piece of it, I'll go back to the simpler one, which represents the lab I've got running right now. The cluster config file and where it sits on its domain, edge being a reserved vocabulary word that I used to say this is hanging off of the internet gateway itself and not behind a subdomain router. And that just points it to a lower level configuration file that defines the OpenShift cluster itself. And here's an example of one that defines a single node OpenShift cluster. It has in it the configuration information that I would have to put into an OpenShift install config.yaml, like the cluster CIDR, the service CIDR that I want it to have, where it's going to get its release image from, in this case, Quay.io. I'm also specifying specification information for a command line utility called Butane that is really, really handy for creating custom machine configs and ignition files for CoreOS. And then I have switches for the release type because I've configured my lab so that I can deploy nightly builds of unreleased OpenShift, or I can build from OKD, the community version, or I can use Fedora CoreOS based images, Stream CoreOS based images, or Red Hat CoreOS based images. So a lot of this is just, things that are specific to my lab for the type of work that I do. And then in this control plane section, I'm defining node specific information. So the whole thing is built around the desire or the ability. Let me show you one that's a little more complex. This is a 3-node example, to declaratively define what I want this thing to look like. And then to operate it, I'll show you just a real quick example. I actually need to change this because that's a collision with an IP address for another machine. So I'm going to change that real quick before I run this command. I'm going to show you one. All of this I run from my CLI that I wrote, which is in that Camaratos directory. But I've got one configured right now. I'm going to show you how easy it is to tear something down. So first I run my lab context command that allows me to choose from the configuration which one I'm working with. And then I'm going to tell it to destroy that instance cluster of the Edge Snow 1. And so what it did is it sent a command to this host, the snow01 cp0.clg.lab host, and it wiped the NVMe drives that are installed in it. It logged into my router and it deleted the DNS entries and it removed all of the boilerplate configuration, including the any load balancer configuration for that lab. So now everything, including the Intel NUC, is completely wiped and completely clean and set back. So this is one of those examples of I don't want to have to touch this. I'll show you a little more interesting, and then I'll pause and take any questions, and that will probably just about wrap us up. So this is an example of running a deployment. So you can see here, it's running the OpenShift install commands with opinionated configuration that my shell scripts are building for it. So it says, okay, I'm configuring one master replica with 0 worker replicas. The rendezvous host IP for the agent boot is the IP address of this node. And now what it's doing is it's taking the ISO image of CoreOS that it pulled from this specific OpenShift install, which is 4.14.11. And it is using the OpenShift command line to create Pixie artifacts from that ISO. That when it's done, it will then push to the router and create one of those iPixie files with the MAC address for that machine. And there it goes. So it's doing that information there. You can ignore that. You can ignore that one little error there, because that's just a configuration that I messed up just a little bit ago. And you can see now it's pushing the initial RAM disk. What you didn't see behind, oops, I didn't mean to grab that, behind these SSH commands here is the configuration that it was doing to the router to set all of that up. And the ignition files that it created. And here's the ignition options that it's putting into the iPixie boot file. And so when this is done, and the longest part of this is just it secure copying into the router the artifacts that it built from my workstation. And when it's done with that, that OpenShift cluster is ready to install. All I have to do is power on the nodes, and in 20 minutes, I'll have a fully configured and running OpenShift cluster ready for application workloads. And the last piece of the no touch that I'm using is because these NUCs support boot over LAN and power over LAN. I'm able to just ping their MAC address and tell them to power on. So there you have it. I hope that was somewhat useful for you guys. Let me see if I can pull Zoom back up, and I'll go back on camera and see what questions you have. Let's see, how do I get Zoom back? There we go.
I do have a question for you.
All right.
On your cabin boy, thing. You have Getia on there? Do you still use Getia? Git with
Yeah,
T?
yeah, so when I set up the Raspberry Pi to be a full self-contained application deployment environment, Git is what I'm using for my SCM. I use Git for the Git server for the source code management. I use Sonatype Nexus for the artifact registry. I use Keycloak for my SSO provider for Open Identity, OIDC, and for OAuth 2.0. And I use Apicurio as a API catalog, API curator, API tester utility. So it builds out what's effectively a small replica of a fully functioning data center that, an app dev team could build and create and run and manage and build and deploy applications on. So it allows me to build it out as a full demo environment for, everything from the metal all the way up to CI/CD pipelines and managing applications running in production.
Secondary question.
Sure.
Can this system be set or to run in a production environment, or is it strictly dev?
Oh no, there's nothing in this environment that tells it where it sits in a CI/CD disposition. That's determined purely on how you use it and how you grant access to it. So there's nothing about it that says I'm only dev or I'm only production. Um, the way I build and configure it, there are a few practices that you would want to change for a full prod environment. Like one, um, you wouldn't use self-signed certs. You'd use real trusted certs. You probably wouldn't just trust the SSH key from the workstation. You'd set up an OIDC for trust with a real bastion server. But as far as the OpenShift cluster and the networking, the routing, the firewall, there's nothing there that wouldn't also be production. Hey Ben, the gear, actually let me go back to the screen share real quick and I'll give you sort of a quick tour. It's actually surprisingly affordable for a given value of affordable, right? I recognize affordable is certainly relative, but
Says the man with the sailboat.
from the cost of an IT gear perspective, like this little picture that you're looking at right here, that gives you the GLINet 1800 AXT, which provides your routing, firewall, DNS, Pixie Boot server, and load balancer. So it's your whole network. That little guy there, depending on prices, it fluctuates from somewhere between $110 to $140 for the GLINet router. And then one of these slim profile NUCs configured with a 16 CPU Intel i7 with 64 gigabytes of RAM, a 1 terabyte NVMe for host path storage for your OpenShift cluster, and then a 128 gigabyte SATA 3 M2 drive for CoreOS to run on. That box there is about 800-ish. So the whole rig, you could have a single node bare metal OpenShift cluster with 16 CPUs, a terabyte of application storage, and 64 gigabytes of RAM, and the whole thing will run you in the neighborhood of $900 to $950. So it's cheaper than a comparable laptop for sure. Let me see. Can I get to the chat from? Oh, here we go. Let me see. Did anybody else ask anything in the chat? I apologize. While I was sharing, I
No,
wasn't able to see
we're
the
good.
chat. All right, cool. Yeah. Any other questions? Main thing I wanted to share with you guys on this is just, the simplicity of limiting the number of configurations you have to deal with and automation over manual tasks, because that's really what Edge is all about. I've got gear deployed somewhere that I can't even get to because it's way up on top of a tower or on a mountain somewhere, but I still have to be able to manage it like I could touch it.
So the question, another question, I'm just gonna throw this out there is, what is the power consumption-ish on this type of setup, both from a single node as well as your
Yeah,
three data center-ish nodes?
yeah, so these guys here, they're not super power hungry, but they're going to consume more power than ARM, right? A similar configuration, which I haven't done, mainly because nobody's built affordable ARM machines that are in this nice tiny little package form factor that I haven't seen. But ARM would use a lot less power. This guy here, I want to say this i7 with, I think it's got the 2 performance cores and then 6 low power cores. It's 40-watt TDP. And so the whole machine, fully loaded with all CPUs screaming, will want 20 volts at 6 amps, that's pretty significant power consumption. Running a reasonable workload, it's 20 volts and it's pulling anywhere from 1.5 to 3 amps.
Sounds good. Do we have any other questions for our guest? All righty, I
All
guess
right.
hearing none, I'd like to thank Charro for the excellent presentation, as well as showing his what he has done, from a NUC perspective, Raspberry Pi perspective, and a small home router type perspective. I believe, I asked Charles if he would look, talk to us, because I think his system or his setup fits really well within the edge computing SIG, because it doesn't require, a whole bunch of power as well as hardware, etc. So it fits right in with what we're looking to do. If the, Other than that, thank you, sir, for that. Another announcement. We have our general OpenShift call tomorrow, same time, 10:11 Central and Eastern. Excuse me, yeah, 11:12, excuse me, Central and Eastern. They're gonna talk about OpenShift, and I believe it was and not something else. I can't think of what it is off the top of my head. Other than that, Mr. Branch, will cut the recording. Hearing nothing else, thank you all for coming, and we'll